Hello everyone, today let's take a look at Quantipus number 62, which is as easy of a conditional probability question that you'll ever get. So we have a population where we have 200 men, where 100 of those men are smokers, 100 women, and 20 of them are smokers, and then it's asking us a bunch of questions, so let's do part A first. So if you can imagine, I have the entire population enclosed within this rectangle, right? So I have 200 men and 100 women. Now it tells us that of the 200 men, 100 of them are smokers, so there's going to be 100 of these total 200 men over here, so there's going to be 100 men that are not smokers. And there are 20 women who are smokers, so if we draw this green box out here, this encompasses all of our smokers, so we'd have 20 women, and then we'd have 80 women who are not smokers. Now part A is super simple, it's just asking us if a random person's chosen from this population, then what's the probability that they are a smoker? So I take the number of outcomes that satisfy my condition, which are 100 plus 20, right? Everything enclosed within the green box is a smoker, so we have 120 total smokers, and there are obviously 300 people total, right? 200 men and 100 women. So this simplifies down to 12 on 30, which is equal to 6 on 15, and that's the answer for part A. Now for part B, it's asking us what's the probability that the person chosen is a smoker, given that that person is a woman. So if we let S be the event that the person is a smoker and W be the event that the person is a woman, then this question is asking us to find the probability of S given W. So we've sampled a person from our population and they've told us that this person is a woman. So now we are restricted down to this blue box. We already know for a fact that this person is a woman. So this blue box is our new outcome space. So it's asking us what's the probability that a person is a smoker given that we're in this blue box? Well, obviously it's just going to be 20, the number of smokers within the box, divided by the total number of people within the box, which is 100, right? So it's going to be 20 on 100, which is equal to 1/5. All right, now let's look at part C, asking us what is the probability that a person chosen at random is a woman, given that that person is a smoker. So instead of the probability of S given W, now we're asked the probability of W given S. So obviously we know that this person is a smoker with 100% certainty in this situation. So now our land of 100% probability, all of our total outcomes fall within this blue box. So now that we've restricted our population to just being within this blue box, now what is the probability that someone is a woman? Well, we have 20 women over here and we have 120 total within the box. So obviously it's just equal to 20 on 120. And obviously this is just equal to 2 on 12, which is equal to 1 on 6. And that is the final answer for part C. So to generalize it a little bit, when we find the probability that some event happens given some other event, we know with 100% certainty that event Y happened. So that just means our new total outcome space is just equal to the magnitude of Y, everything that's within this set Y. Now for the numerator, the number of outcomes that satisfy this condition X given Y are the number of people who first exist in Y and are also a member of X, right? So X intersection Y. And this is also the exact same thing as saying the probability of X intersection Y divided by the probability of Y. That's just because the probability of X intersection Y is obviously the magnitude of X intersection Y divided by the total of the entire population to begin with, right? And on the bottom, the probability of Y is just equal to the magnitude of Y also on the total. And then obviously the totals are going to cancel out. So you can see that this is just equal to X intersection Y on the magnitude of Y, but it's more useful to think about it this way in the future problems because we're going to deal with probability more so than just counting like we were doing here.